see that this LED is here at B6 and this is at the B5. It is on by default and we need to turn it on using this tick tick button. I press it, see it's pressed, but as soon as I release it, see it goes here. Now the bit is locked, it's on forever. So that's how we are going to use the bit locking. Again I press it, nothing happens, but as soon as I will release it, see it goes back to the other state. So you press the button, but as soon as you release it, it goes into the holding state. This LED is on and this is off now. This is hold it here. Now again I do the same, it's back to the initial state. Again same, see. So that's how the bit holding takes place. We send a bit and then we hold it to do various tasks. Hello guys, welcome to learning microcontrollers. In this video I will show you how you can use a bit, you can do the bit holding in MikroC using while loop. So guys, I will be using a PIC16F877A microcontroller for demonstration purpose. Bit holding is very important technique whenever you are dealing with sensors or modules, even with a push button as well, momentary push button, you have to hold the bit. Like you press a button tick, a 1 is sent. Now once you release the button, 1 is sent. So just like you do the latching, here in microcontroller using the programming, how you will do the bit holding, this tutorial will deal with that. So let's get started. So first of all, we will set up our hardware, then we will do our programming. So what hardware I'm going to have is just a microcontroller, PIC16F877A, a push button which will send a 1 when pressed and else it will be 0. And then we will have 2 LEDs and that's all. Once I set up the hardware, then I tell you what's going to happen. So first of all, we set up the hardware. So this is our push button. It has 2 pins. It's a non-polar component. You can shuffle these 2 pins as well, doesn't matter. So we will need a 10 kilo ohm resistor to interface this with a PIC. Now guys, you can name the one pin as signal, other one as a VCC. You can shuffle these 2 pins, it doesn't matter. Now guys, first of all, connect the VCC pin to the VCC of the PIC like this. Like we will give the 5 volt to the button and to the PIC as well. Now the signal pin, you will send it to the one end of the 10 kilo ohm resistor like this. From the same pin, you will take out your output. You can use any available digital input output pin of the PIC. I'm going to use a pin number 15, that is C0 like this. Then guys, from the other end of this 10 kilo ohm resistor, you send it to the common ground like this. Now guys, this is our first LED. We will have to roll up 2 LEDs. As you can see that this LED has 2 pins, one longer, one shorter. The longer pin is the power, the shorter is the ground. Unlike the button, it is a polar component. You cannot shuffle these 2 pins at all. Longer is always a power, shorter is always a ground, that's all. Now I name the longer one as power, shorter one as the ground. Now to interface this with a PIC, you will connect the shorter pin to the ground of the PIC like this. Now for the longer pin, you will need a resistor, a safety resistor. It can be any from 100 to 500 ohm. Even if you go higher value, it will work, but higher the value, the dimmer the LED will get. So 220 ohm is an ideal value. I always use this, so you can use this as well. So connect the longer pin to the one end of the 220 ohm resistor like this. From the other end, connect it to the any available digital input output pin of your PIC. I'm going to use a pin number B5 for this like this. Now the other LED, similar story. Longer pin, shorter ground, longer power, and then a 220 ohm resistor. Connect the longer pin to the one end of the 220 ohm resistor like this. From the other side, other pin of the 220 ohm resistor connected to any available digital input output pin. I'm going to use a pin number B6 for that like this. Similarly, its shorter pin is a ground connected to the common ground like this. Now this is our circuit. So whenever this button is pressed, a 1 will be sent. Why? Because this 10 kilo ohm resistor is at the grounding end. Whenever the 10 kilo ohm resistor is at the grounding end, it means whenever the button will be pressed, a 1 will be sent to the microcontroller, else it is sending a 0. So now this is what we are going to use here. We will do the bit locking. This is a momentary push button. Whenever you press it like tick, it sends a 1 and you release it, it's again 0. It's only 1 whenever it's pressed for just a minute some milliseconds. Now we have to do is that by default this LED B6 will be on. Now this LED at B5 will turn on as soon as a 1 comes and then it will remain on. Even if you have released the button, you have pressed the button and you have released the button, this LED will turn on and this will turn off. And that's called bit locking. It will be on without any external like flag. And then whenever you will press this button again, it will go 1 and as soon as you release it, it goes 0. This LED will turn on and again by default this will turn on. This will turn off and this will turn on by default. So once you press and release the button, this LED turns off, this one turns on. and again you press and release a button, this LED will turn on and this will turn off. So we are doing here is called bit locking here. Now in case of sensors on modules, there are various tasks whenever a sensor has to send some value, and for that it sends a flag. Like take the example of DHT11 sensor. It sends a ready command after 80 milliseconds. So you will use the bit locking technique here, that as soon as you get the ready one, then you will be ready to read the data and you will store that data of temperature, humidity, whatever. So there are various other sensor modules as well which will use the bit locking technique. Even the buttons require bit locking technique. So let's get to the hardware now before we move on to the programming. So let me erase any previous code that I have. So let me connect the camera. So guys, this is the hardware. As you can see, this is the button I'm going to use, this push button. See, it's a tick button, and two of these LEDs will be used, one here and one here. Now guys, this is our PIC16F877A, and that over there is a PIC 3.5. So don't worry about the hardware. I will share the link of a video in which I had shown you how you can set up this hardware. That video link will be in the description, so don't worry about it. So let's get to our MikroC here. Let me zoom in. So guys, this is MikroC for PIC version 7.2.0. You can use a higher version as well. Higher is always better. Click on new project. This window pops up, new project wizard. Click on next. Write the name of the project, bit holding tutorial by learning microcontrollers 1. Now this is the path where the files will be created. Select the microcontroller. I'm going to use a PIC16F877A, and 20 MHz is the crystal at the pin number 13 and 14 of the PIC on my hardware. So you will write that value over here. Click on next and finish. Now guys, before you do anything else, first of all, save your work. Press Ctrl S to save your work like this. Now guys, the next thing is we have two LEDs. Initialize them. Write down trace B dot F5 equals to 0. That's the first LED at pin number B5, and 0 means it's an output. So we are giving it direction of output. Now guys, initially the LED must be off. Port B dot F5 equals to 0, and give some initialization delay. This is not necessary to give initialization delay, but I always suggest you give it in the one-time loop. Now guys, copy this for the second LED at B6. Initialize it as well. So this is a second LED at B6 like this. Now guys, second LED is also initialized. Now we go for our button. Again copy paste it. Button is at C dot F0 like this. And for the button, pin direction must be 1. 1 means it's an input and 0 means it's an output. So for the button is always connected to the input pin. So our grounding resistor, our 10 kilo ohm resistor was at the grounding end. So whenever the button is pressed, a 1 will be sent. So by default it must be 0. Now this is our initialization delay. That's all. So button is initialized, two LEDs are initialized. Now we go to our forever loop. Write down while 1. Now as I told you, by default the LED at B6 will be on. So we turn on this LED at B6. I make it 1, and the other LED which is already off, I again make it off because we have to repeat here. So now by default these two LEDs are on. As soon as the code runs, these LEDs are on. Now for the other LED, whenever a button is pressed, only then it will turn on. So here to check if the button is pressed, I use this command while this mark. Now write the name of the pin, port C dot F0, double bracket close off. Now this command over here checks if now this will block the code here. The code is blocked here. Only the code will move forward if this condition is satisfied. This is called holding. We are holding the code here by using this statement. And if we remove this, now if the button is pressed, then a 1 will be sent. As soon as the 1 is sent, we again use this. Now remove this. Now this is checking for 1. Checking for 1 if the button is pressed. If button is pressed, okay, if the button is pressed, now this is checking for 0 if the button is released. So if the button is pressed, only then the code will proceed. Okay, make it ports. Sorry, I forgot the T here. So if the button is pressed, only the code will proceed to the next line, that is the button release. Now if the button is pressed and then released, now it will turn on the other LED and it will turn off this LED like this. Now the other LED, that is at B5, will turn on and this will turn off. That's how we are doing the bit holding here. Now again, this should remain this like this in the same condition. It is now in the same condition. No, okay, let's build and write this code and see what happens. We will move on to further programming after we get, okay, go to PIC programmer tool, click on import hex file. This is the file we just created. Click on select the file, click on write. Okay, the new file is being written. Let's get to the hardware. Okay, you can see the LED blinking because we are using pin number B6. B6 is also the PGM pin, so that is connected to the PIC as well. So whenever programming is taking place, this LED blinks. So you can see that pin B6 is now on. That's perfect. This pin must be on. Now the button is not pressed as shown in the programming. See, as soon as our code starts, the pin at B.F6, the LED at this pin is on. So that's perfect. And the other LED is off. Now once the button is pressed, as per our expectation, this LED will turn on and then we will block the code here. Now then the code will be here. So code will be here, it will not be blocked, but the other LED has to turn on. So we go to our programming, I press the button, I press it, I release it. See, it is doing it too fast. It is very fast. We cannot see with our naked eye what is happening here. So what I do is that I slow down the code so you guys can understand what is happening here. I make it like a 500, okay, 1 second delay here. So whenever it goes here, it will be a 1 second delay. So you guys can see what is happening here. Now I click on write. Okay, the new code is being written. It's written. I just paused it so we can save time. See, now I have given some delay. See, it's 1 second delay. Again, it got back. See, it went to that, but it came back. So this command is just like using if and else, but it's a short form of that. Now we need to hold this code. We don't want the delay. We want the holding here. To hold the code, you will use a forever loop here. While 1. Now this is our forever loop. Now by default we were here. Now we check if the button is pressed. So if the button is pressed and then if the button is released, only then it will lock the code. Now the code is locked here. Now we build this code and let's see what happens. Now this is the next step of bit locking. See, let me, okay, the code is burned. I pause the video so we can save time. See, again it's perfect. LED at B6 is on. Now I press the button. See, now it's locked. Now the B5 is locked, but now we want to get back to the initial state. We cannot. So we have to break out of this lock as well. Now the bit locking has, this is called bit locking. Now see that we use these two conditions to make sure that the button is pressed is detected. Now button is pressed, as soon as it is released, it is detected that the button has been pressed and button has been released, and we lock the code here. The LED at B5 is on and this is off. Now it is here forever. Now we break out of this loop. To break out of this loop, what we do is that we again do the same. We again check if the button is pressed. We will use the same button to break out of the loop. Now see, again we check if the button is pressed, means the one is received. Then if the button is released, it is pressed and then it is released. What it will do? It will break, write down the break statement here. It will break out of the forever loop. And again it will check if the button is pressed or not. So let's build this. I click on, go to the PIC programmer tool. I click on write. The new code is being written. Let's zoom out and wait for the new code to be written. Okay, let it write. Okay, it's written. We power it up using PIC3. See, that's perfect. The LED at B6 is on by default. Now I press the button. See, we are here now. I press the button. See, again we got out of this. Now we are in the normal state. I press the button. Now it's pressed. I am not releasing it. It is not going into that state. Why? Because it's pressed. But our condition is that right next to the press command, we have a release command. As soon as this will be released, only then it will go into the holding state. Now it's holded. I press the button. It's pressed. I will not release it. Even I keep it pressed forever, it will remain like this. It will not go back to the other state. As soon as it will be released, a 0 will come. See, it breaks the loop. It goes. Now it goes to the break statement and goes out of the forever loop. See, again, it's pressed and released. Pressed, released. If I do it quickly, see, still it has a great speed. See, it is working perfectly. That's how it should work. See, now it's bit is locked. I press it twice, bit is locked, and now we want to come out of the forever loop. See, like this. Now let me give you an overview. See that here we initialize our LEDs and buttons here, and then our one LED is on by default, other is off. Then we check if the button is pressed. If it is pressed, then we must check if it is released or not. This command differentiates it from press and release. If this is here, it is checking for 1. If this is not here, exclamation mark, it means it is looking for 0. So once we are sure that button is pressed and released, then we lock the bit. This is a bit locking command, that is forever loop. We had locked the code here. But now as soon as the button is pressed, now it is waiting for the button to be released. As soon as the button is released, it breaks out of the loop. That's all. So guys, this is it. If you have any questions, you can ask in the comment. Thank you very much for your time. We'll see you in the next video.